Welcome to MarkScheme. What is a function? Everything you need made visual. Picture a vending machine. You press one button, B4, and out comes exactly one thing. One press, one snack. Every single time. That is the whole idea of a function. A rule that takes an input and gives back exactly one output. So here's the question that decides everything. What if you pressed one button and two different snacks fell out? That machine is broken. And in maths, that broken rule is simply not a function. By the end of this, you'll be able to spot the difference at a glance and read a function's domain and range straight off a graph. Here's exactly what this covers, straight from your syllabus. IB analysis and approaches. Standard level 2.2. A function as a mapping. The one output rule. Domain, range, and the graph. The notation f of x and f maps x to something. And the informal idea of a one-to-one function. There are no prerequisites here. This is the very start of topic 2. So if you're building up the whole course, you're in the right place. Let's make that concrete. A function is a machine with a rule inside it. Feed in a number x on the left. The rule works on it. And out comes one number, ff, of x on the right. Our machine's rule is square the input, then subtract 3. Watch 1 go through. Put in 2. The machine squares it, 4, then subtracts 3, leaving 1. So f of 2 is 1. Notice the key thing. 2 goes in, and exactly one number comes out. Not 2 answers, not a maybe, 1. Write that down, because everything in this topic hangs off it. The rule of a function. Each input gives exactly one output. Break that rule. Let one input produce two outputs, and it stops being a function. That single sentence is the test we're about to turn into a picture. Here's how to see the one output rule on a graph. The vertical line test. A vertical line stands for one fixed input, x. Sliding it across asks, at this x, how many y values does the curve give? Take our parabola and sweep a vertical line through it. Everywhere it goes, the line meets the curve exactly once. One input, one output, all the way across. It never catches 2 points at the same time. So the parabola passes the vertical line test. It is a function. Now a circle. Sweep the same vertical line. In the middle, it slices the circle at 2 points at once. One input, x, giving two different y values. That breaks the one output rule on the spot. So the circle fails the vertical line test. It's a relation, but not a function. One clean rule to remember. If any vertical line can hit the graph more than once, it's not a function. That's the one output rule made visible. 2 bits of notation now, and they mean the exact same thing. The first is f of x equals x squared minus 3. Here, f is the name of the function, and f of x is the output you get when the input is x. The x in the bracket is a placeholder. Whatever you drop in there, the rule acts on. The second uses the little bar and arrow. F maps x to x squared minus 3. It says the same thing in mapping language. F sends each input to that output. IB uses both, so get comfortable reading either. To evaluate, just replace the placeholder. f of 4. Put 4 where the x sits. 4 squared minus 3 is 13. f of 0. 0 squared minus 3 is minus 3. Whatever's in the bracket goes everywhere x was. Every function comes with two sets. The domain is all the allowed inputs. The x values you're permitted to feed into the machine. The range is all the possible outputs. The y values that actually come out. Domain in, range out. Mix those two up, and you'll lose easy marks. So keep them straight. Inputs, then outputs. For most functions, the domain is every real number. A polynomial like x squared. Minus 3 happily eats any x. You only restrict the domain when the rule would break. And in SL, there are two culprits. 1. Division. You can never divide by 0. So 1 over x minus 3 forbids x equals 3. 2. Square roots. You can't square root a negative. So the square root of x minus 2 needs x at least 2. Spot a denominator or a root, and go hunting for the banned inputs. Here's the picture that makes range click. Let a point ride along the curve. Drop a line straight down to the x-axis, and you read off the input. Run a line across to the y-axis, and you read off the output. Now sweep the point across the whole graph, and watch the two shadows it casts. As the point travels, its shadow on the x-axis sweeps out every input we use. That's the domain. And its shadow on the y-axis sweeps out every output we get. That's the range. Watch the y shadow. It dips right down to the bottom of the curve and then climbs. But it never goes below the lowest point. So there are the two answers, straight off the graph. The domain is the whole x-axis. Every real number is a legal input. The range is the y-axis, from minus 3 upward, because the curve bottoms out at minus 3 and opens up forever above it. Range is y greater than or equal to minus 3. Reading range is really just reading the height the curve reaches. It's shadow on the y-axis. One last idea, kept informal for SL. We've used the vertical line to ask, is this a function? Now use a horizontal line to ask a different question. Is it one-to-one? A one-to-one function never sends two different inputs to the same output. Look at the straight line on the left. Any horizontal line meets it just once. So every output comes from a single input. That's one-to-one. The parabola on the right is different. A horizontal line hits it at 2 points. Two different inputs, plus and minus, giving the very same output. It's still a function. It passes the vertical test, but it is many-to-one, not one-to-one. Why care? Because only one-to-one functions can be perfectly undone. And that's the whole story of inverse functions coming up in this topic. Time for worked examples. Easy to hard. All my own. Number 1. With f of x equals x squared minus 3. Find f of 2 and f of minus 1. And then decide whether a graph that a vertical line crosses twice is a function. Substitute carefully and mind the brackets. F of 2. 2 squared is 4, minus 3 is 1. F of minus 1. Watch this. Minus 1 squared is positive 1, because a negative times a negative is positive. 1 minus 3 is minus 2. The brackets around the minus 1 are what save you here, and the test part. If a vertical line crosses a graph twice, that's one input giving two outputs. It breaks the one output rule, so it is not a function. 2 quick marks, banked. Number 2. The classic. State the domain and range of the square root of x minus 2 and of 1 over x minus 3. Same drill each time. Find the band inputs for the domain, then think about what outputs the rule can produce for the range. The square root first. You can't root a negative, so whatever's inside must be at least 0. X minus 2 greater than or equal to 0, giving domain x greater than or equal to 2. For the range, a square root only ever hands back something 0 or positive. So range y greater than or equal to 0. Now the fraction. You can't divide by 0, so the denominator can't be 0. X minus 3 not equal to 0, giving domain x not equal to 3. And the range. Here's the subtle one. 1 over something can get tiny, but it can never actually equal 0. No input makes this fraction 0. So the range is y not equal to 0. Every root and every denominator is a clue to a restriction. Number 3. A level up. Find the domain and range of the quadratic x squared minus 4x plus 1. The domain is the easy half. It's a polynomial, no roots, no denominators. So every real number is allowed. Domain is all real x. The range is the interesting half. And it's all about the vertex, the turning point. This parabola opens upward, so it has a lowest point, and the range starts there. The vertex sits at x equals minus b over 2a. Here that's 4 over 2, which is 2. Put x equals 2 back in to get the lowest output. 4 minus 8 plus 1 is minus 3. Since the parabola opens up from there, every output is minus 3 or above. So the range is y greater than or equal to minus 3. Domain, all reals. Range, from the vertex up. Read the range of the turning point every time. Now, the exam graph, other channels skip. The single biggest time saver. When a question asks for the range, don't stare at algebra. Put the function into your GDC, graph it, and literally read off how high and how low it goes. The calculator shows you the range. 4 rules to bank. 1. Use the GDC to see the range. Vertex and behavior, asymptotes. 2. No interval notation. X at least 2 is the interval, 2 to infinity. 3. To find excluded inputs, set any denominator not equal to 0, and set the inside of any square root greater than or equal to 0. And 4. Always do domain first, then range. The inputs you allow decide which outputs you can even reach. Finally, the 3 traps. 1. Swapping domain and range. Burn it in. Domain is the inputs, the x values. Range is the outputs, the y values. 2. Forgetting a restriction. Every denominator and every square root is a place the domain can break, so check each one for band x. And 3. Mixing up the 2-line tests. A vertical line tells you if it's a function at all. A horizontal line tells you if it's one-to-one. Keep those straight. And SL 2.2 is free marks. And that's SL 2.2, fully covered. A function is a machine giving exactly one output per input. The vertical line test that checks it. The notation f of x. And how to read off domain and range, restrictions, and all. Next in the course, we turn functions into pictures, graphs, and their key features. For more, that's markscheme.app. See you there.